Now let's talk about something that's going to absolutely destroy your faith in corporate ethics. A train manufacturer that secretly programmed their vehicles to break down if they detected they were being repaired by competitors. This isn't science fiction, this is documented corporate sabotage that required actual hackers to solve. To understand this story, we need to start with Poland's remarkable railway transformation. For decades, like many Eastern European countries, Poland's rail network had been neglected and underfunded. But in the 2000s, something changed. The country began investing heavily in modernizing its railway infrastructure, upgrading routes, and expanding passenger services as part of broader European integration efforts. The Voivodeship of Lower Silesia became particularly active in this modernization push. Around Wrocław, one of Poland's major cities, railway lines were being expanded and stations modernized. The region was investing millions of euros in new rolling stock to serve both regional passengers and freight operations. In regional transport, Polish operators made a strategic decision to rely heavily on domestic manufacturers. This wasn't just about supporting local industry. Companies like Pesa and Newag, later known as Newag, had developed expertise in building trains specifically suited to Polish operating conditions and requirements. Newag's flagship product was the Impulse train set, first introduced in 2012. These were modern, efficient multiple-unit trains available in various configurations, 3-car, 4-car, and 5-car versions designed for regional passenger service. The Impulse trains represented the cutting edge of Polish railway technology, featuring modern traction systems, passenger amenities, and computerized control systems. The Lower Silesian Railways ordered several Impulse 45 units, 5-car train sets that entered service around Wrocław in 2017. These trains were a significant investment, costing millions of euros each, and represented the future of regional rail transport in the area. For the first few years, everything worked perfectly. The trains provided reliable service, passengers appreciated the modern amenities, and the railway operators were satisfied with their investment. But then came the scheduled maintenance requirements. After approximately 6 years of operation, the Impulse 45 trains required comprehensive general inspections, major maintenance overhauls that are mandatory for railway vehicles. This wasn't routine servicing, but extensive work involving complete disassembly, inspection of all major components, and replacement of worn parts. The maintenance contract was put out to public tender, as required by European Union procurement rules. Multiple companies could bid on the work, including the original manufacturer Newag and independent maintenance providers. The contract was awarded to SPS, Serwis Pojazdów Szynowych, an independent train maintenance company based in a small Polish town. SPS specialized in professional railway vehicle maintenance and had the facilities, expertise, and certifications required for this type of work. This was completely normal and legal. In the railway industry, just like in aviation or automotive sectors, independent maintenance providers regularly service vehicles they didn't manufacture. In spring 2022, the first Impulse 45 arrived at SPS facilities for its scheduled overhaul. The maintenance team followed the comprehensive 20,000-page instruction manual provided by Newag, performing every required check, inspection, and component replacement. The work was completed according to specifications. Every system checked out. All safety requirements were met. But when the train was supposed to leave the maintenance hall under its own power, something bizarre happened. The onboard computer system displayed a vague error message, and the traction inverters, the electronic systems that control the electric motors, refused to start. The train was essentially paralyzed, unable to move despite being mechanically and electrically sound. SPS technicians ran through every diagnostic procedure they could think of. They checked electrical connections, tested control systems, and verified that all maintenance work had been completed correctly. Everything appeared to be functioning normally, yet the train remained immobilized. A second Impulse 45 underwent identical maintenance procedures with the same result: complete paralysis after what should have been routine service. The maintenance work was flawless, but the trains simply refused to operate. Desperate to clear their maintenance haul, SPS attempted to couple a third train, one that was due for maintenance but still fully functional, to one of the immobilized units. The plan was to use the working train to push the disabled one out of the facility. But the moment the electronic coupling process began, the third train also became immobilized. Whatever was causing the problem was apparently contagious, spreading through the train's electronic systems during the coupling attempt. The situation quickly became a financial nightmare for everyone involved. SPS faced penalty payments to the railway operator for delayed return of the trains. The railway operator, Koleje Dolnośląskie, faced capacity restrictions because they operated a relatively small fleet. Losing 2 or 3 trains meant significant service reductions. Newag, the manufacturer, was contacted for technical support but refused to provide assistance. Their position was that the maintenance work performed by SPS was of insufficient quality and that the trains should be serviced only by authorized Newag facilities. The standoff continued for months, with millions of euros worth of modern trains sitting immobilized in a maintenance facility, unable to return to passenger service. Faced with mounting financial pressure and no cooperation from the manufacturer, SPS made an unusual decision. They contracted Dragon Sector, a group of cybersecurity researchers and ethical hackers, to investigate the problem using digital forensics techniques. Dragon Sector wasn't a typical maintenance contractor. They were specialists in reverse engineering, software analysis, and cybersecurity. Their involvement suggested that SPS suspected the problem wasn't mechanical but digital. The hackers obtained access to one of the immobilized train sets, along with spare computer systems and all the software files from the train's control computers. Their mission was to determine why mechanically sound trains were refusing to operate. What followed was essentially digital archaeology. Working without blueprints, source code, or manufacturer cooperation, the Dragon Sector team had to reverse engineer the train's control software to understand its internal logic. This process, known as reverse engineering, involves observing how software behaves under different conditions and gradually reconstructing its internal decision-making processes. It's painstaking work that can take months, especially with complex industrial control systems. The hackers analyzed thousands of lines of compiled code, traced software execution paths, and compared the behavior of working and non-working systems. They were looking for the digital equivalent of a smoking gun, some piece of code that was deliberately preventing the trains from operating. After weeks of analysis, Dragon Sector made a disturbing discovery. Embedded within the train's control software were GPS coordinates, specific latitude and longitude positions that corresponded to railway maintenance facilities across Poland. The coordinates weren't random. They precisely marked the locations of SPS and other independent maintenance companies that competed with Newag for service contracts. The software was literally programmed to know where these facilities were located. But the coordinates weren't just for identification. They were part of an active sabotage system. The software included logic that would disable the train if it remained within these specific geographic areas for more than 10 days. The GPS-based lockout wasn't the only sabotage mechanism Dragon Sector discovered. The trains also contained code that would prevent operation if components with unauthorized serial numbers were detected, even if those components were technically identical and fully compatible. This meant that even using genuine Newag parts could trigger the lockout if they hadn't been specifically authorized for that particular train. It was a digital authentication system designed to prevent any maintenance work that wasn't directly controlled by the manufacturer. Some reports suggested there had originally been a manual override, a specific key combination that could be entered in the driver's cab to bypass these restrictions. However, after media reports began circulating about the Impulse 45 problems, the remaining trains apparently received software updates that removed this override capability. Newag's official statement said they categorically denied ever having implemented any functions that could restrict proper operation or limit the circle of possible maintenance companies. They portrayed SPS as a competitor with obvious financial motivations to make false accusations. The manufacturer even contacted Polish transport authorities, arguing that the trains should be taken out of service because it was unclear what methods had been used to modify the safety-critical software. They essentially argued that the trains were now unsafe because hackers had tampered with them, ignoring the fact that the hackers had only removed Newag's own sabotage code. Dragon Sector's investigation revealed that the sabotage wasn't limited to the trains at SPS. Nearly 24 impulse trains across Poland had been affected by similar lockout mechanisms. The software-based sabotage was apparently a systematic feature built into Newag's products. The hackers were able to restore operation to all the affected trains by removing or bypassing the sabotage code. This proved that the trains had never been mechanically defective. They had been deliberately disabled by their own manufacturer. The scandal reached the highest levels of Polish government. Poland's Minister for Digital Affairs publicly stated that the available evidence pointed more toward Newag's guilt than toward any wrongdoing by SPS or the hackers. Newag responded by filing lawsuits against SPS, Dragon Sector, and other parties involved in exposing the sabotage. The company claimed defamation and copyright infringement, seeking 1.3 million euros in damages for alleged reputational harm. SPS filed countersuits demanding public apologies and compensation for the extended train downtime that had cost them significant money and damaged their reputation. The Newag case represents a landmark in the global right-to-repair movement. It demonstrated how manufacturers can use software locks to prevent independent maintenance, even when that maintenance is performed to the same standards as factory service. This practice isn't limited to trains. Similar software-based restrictions have been found in tractors, smartphones, medical devices, and other products where manufacturers want to control the aftermarket service business. The case also highlighted the growing importance of cybersecurity in industrial systems. Modern trains, like modern cars, are essentially computers on wheels. When those computers are programmed with malicious intent, the results can be devastating for operators and passengers. The sabotage system was remarkably sophisticated. The GPS coordinates were embedded deep within the control software, making them difficult to detect without specialized reverse engineering tools. The 10-day timer was apparently designed to allow for brief visits to competitor facilities without triggering the lockout, perhaps to avoid suspicion during initial diagnostic visits. The component authentication system used cryptographic techniques to verify that parts were authorized for specific trains. This level of sophistication suggests that the sabotage features weren't afterthoughts, but were designed into the system from the beginning. As of the latest reports, the legal disputes between Newag and SPS remain unresolved. However, the affected trains have been returned to service after Dragon Sector's intervention removed the sabotage code. Significantly, when Koleje Dolnośląskie needed to order additional trains, they chose Pesa, Newag's competitor, rather than purchasing more impulse units. The scandal had effectively destroyed Newag's reputation in the Polish market. Second, it shows the importance of independent security research. Without Dragon Sector's intervention, the sabotage might never have been discovered, and Newag could have continued blaming poor maintenance for problems they had deliberately created. The Newag scandal isn't an isolated incident. Similar practices have been documented across multiple industries. John Deere has used software locks to prevent farmers from repairing their own tractors. Apple has implemented serialization that prevents independent repair of iPhones. Tesla has restricted access to parts and diagnostic tools for independent repair shops. Medical device manufacturers have used software locks to prevent hospital technicians from servicing equipment. When manufacturers can remotely disable products they've already sold, the traditional concept of ownership becomes meaningless. If train manufacturers can do this, what's to stop car manufacturers from disabling vehicles that visit independent mechanics? Or smartphone manufacturers from bricking phones that are repaired by unauthorized shops? Until next time, this is Martin from sunny Cape Town. For this video, I used Fliki AI with my own cloned voice due to the fact that I am not a native English speaker, but I carefully researched his video and put quite a lot of work into it. So I hope you like it, and please hit the subscribe button. See you soon.